everyone, in this video we will be solving exponential equation. This is the first part. I will put the link of the second part in the description box below. In an exponential equation with the form b to the power x is equal to b to the power y, the exponent of the left side x and the exponent on the right side y would be equal to each other. X is equal to y if the base b on both sides are the same. So in this example that we have here, as you can see, we have the base of both sides of the equation are 5 and 5. Now, we can therefore say that in order to solve for x, this exponent on the left side would be equal to the exponent on the right side. So then we can go ahead and, in order to solve for x, this would be 2x plus 4 is equal to 7x minus 1. Again, we can do this because they have the same base. So both of them are 5. If this one is not 5, then we cannot make use of this concept that we have here. So then we are going to, we want to solve for x. So we're going to subtract 7x from both sides minus 7x. So then we can go ahead and cross the 7x out. So we're left with negative 5x plus 4 is equal to negative 1. So then we want x by itself. So we are going to subtract 4 from both sides minus 4. So then we are left with negative 5x is equal to negative 5. So then we're going to divide both sides by negative 5. So divide this by negative 5, divide this by negative 5. So then we are left with x is equal to positive 1. And then we are going to check if we get the answer correct, if both sides of the equation are equal. So then we are checking this answer that we have over here. So then I am going to use the original equation that we have there. So this would come out to be 5. And then the exponent is 2x plus 4. Instead of x, we're going to put in 1 to it. So this would be 2 times the 1 that we got plus 4. Is that equal? We're not sure of it yet. Is that equal to 5 to the exponent? That would be 7. And then we put in the 1 that we got minus 1. So let's see if both sides of the equation are equal. So again, the x will turn into 1. And then this is 1 right here. So then we have 5 to the power. 2 times 1 is 2. Plus 4, is that equal to 5 to the power? We have 7 times 1 is 7 minus 1. So then we can go ahead and say 5 to the power 6 is equal to 5 to the power 6. So that means our x value is correct. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So as you can see, both bases are the same. So if both bases are the same, that means their exponents are equal to each other. So we're going to equal this 10x minus 3. We're going to equal that with 2x plus 5. So we can set up our equation as 10x minus 3 is equal to 2x plus 5. So then from here, we are going to subtract 2x from both sides minus 2x. So we are left with 8x minus 3. And then that is equal to 5. So then we are going to add 3 from both sides, plus 3 and plus 3. So then we are left with 8x is equal to 8. So we're going to divide both sides by 8. I'm going to divide this by 8. So then we are left with x is equal to 1. So our x value is 1. And then again, we are going to check our work if we got it right. So what we do is we plug the value of x that we got into the original equation that we have up there. So let's see if that will equal each other. So that's 13 to the power. That's going to be 10. And then we put in the x that we got minus 3. Is that equals? We're not sure of it yet. I put a question mark on it. That is 13 to the power. That would be 2 times the x that we got. And then plus 5. So let's put in the x. Again, our x value is 1, so I put 1 right there and put 1 right there. So then we have 13 to the power 10 times 1 is 10 minus 3. Is that equal to 13 to the power? That's 2 times 1 is 2 plus 5. So then we go ahead and simplify it. That would be 13 to the 7 is actually equal to 13 to the 7. So both sides of the equation are equal. Did you get the same answer as this? Good. Perfect. Now let's move on to this next example right here. So as you can see in this next example, we don't have the same base. The base of the first one is 7. And the base of the second one is 49. So both bases are not the same, so we cannot equal them to each other. So because others are gonna just equal them to each other because like it's exponential, that's not how it works. That's not the correct way. We cannot equal them to each other since their bases are not the same. So, but we can, our task is to make their bases the same because we can make them the same. So if I'm gonna rewrite this as 7 to the power, so that would be to the power 3x plus 12. So I'm going to write that up here. So 7 to the power 3x plus 12. I'm going to change this 49 to the base of 7. And 49 is actually 7 squared. So I can go ahead and change this 49 into 7 squared. So then we, again, 7 squared is 49. And then I'm just going to write the exponent negative 2x minus 1. And then from here, we are going to distribute the 2 to both terms inside the parentheses here. So distribute, again, it has to be both terms because others missed this part. They only distributed it to the first term. So it has to be to both of them. So looking at this, we have 7 to the power 3x plus 12 is equal to, that would be 7 to the power. This is already negative 4x, and then that would be negative 2 because you have negative 2 times negative 2x is negative 4x, 2 times negative 1 is negative 2. So as you can see here, we already have the same base. Okay, so then we can go ahead and equal these two exponents to each other since we already have the same base. So then we can solve for x. That would be 3x plus 12 is equal to negative 4x minus 2. So we want x by itself, so we're going to add 4x from both sides plus 4x. So then we are left with 7x plus 12 is equal to negative 2 because we can cross negative 4x and 4x. So then we are going to subtract 12 from both sides minus 12. So then we are left with 7x is equal to negative 14. So we're going to divide both sides by 7. So divide this by 7 and divide this by 7. So we can cross that out. So our x value is negative 2. So that is the x that we have. Now, we check our work because others are going to say, how do we know if we really got it right? So we're going to check our work here by plugging the negative 2 back into the equation. But we're going to use this one right here. So we're going to use this equation since they already have the same base. But then again, these two are actually equivalent equation, so they're just the same thing, but we're going to use this as we already have the same base. So that would be 7 to the power, that would be 3 times the x that we got plus 12. Is that equal, so we're not sure of it yet, to 7 to the power, that would be negative 4 parentheses minus 2. So again, the x that we got is negative 2. So I'll put that in here, negative 2. So then this would come out 7 to the power. That's negative 6 plus 12. Is that equal to 7 to the power? That's negative 4 times negative 2 is 8 minus 2. So then we go ahead and simplify it. That would be 7. Negative 6 plus 12 is 6. And that is equal to 7 to the power 8 minus 2 is 6. And so we got both sides of the equation equal to each other. This time I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we have 8 and 2, and so their bases are not the same, so we cannot equal them to each other, because others are just going to go ahead and say, oh, that's 4x minus 7 equals 5x. That's not the way how we do it, because we don't have the same base. It has to have the same base first. So this 2 can be expressed with a base of 8. So I can go ahead and write this as 2 to the power. How many times do I multiply 2 so that I can get 8? That would be 3. That means if I multiply 2 times 2 is 4 times 2 is 8. And then we have an exponent of 4x minus 7 is equal to 2 to the power 5x. And so from here, we are going to distribute the 3 to both terms inside the parentheses. This would be distributed to that and distributed to that one over there. So this would come out 2 to the power. That would be 12x minus 21. So that is 12x minus 21. And that is equal to 2 to the power 5x. At this time, you will see that they already have the same base of 2. So then from here, we can equal these two exponents to each other since their bases are the same. So I can go ahead and write 12x minus 21 equals 5x. So then I go ahead and subtract 5x from both sides because I want x by itself. So minus 5x and minus 5x. So we can cross the 5x out. We're left with 7x minus 21 equals 0. So then we're going to add 21 from both sides plus 21. So then we are left with 7x is equal to 21. We divide 7 from both sides, divide 7. So then our x is, so this is supposed to be 7. So our x is 3. So we check our work if we got it right. Again, to check the work, we are going to use this equation that we have here that we already got the same base. So that would be 2 to the power. That's 12. And then the 3 that we put in minus 21. Is that equals? We're not sure of it yet. So that would be 2 to the power 5 times the x that we got. Again, the x that we got here is 3. So I put in 3, I put in 3. So then if we simplify this, this would come out 2 to the exponent. 12 times 3 is 36. Minus 21, is that equal to 2 to the power 15? So 36 minus 21 is 15, and that is equal to 2 to the power 15, which means that our x value is correct since both sides of the equation here are equal to each other. Did you get the same answer as this? Good. Perfect. If you find this video helpful, please like and subscribe for more math videos. See ya!